Good afternoon, good morning, good evening, whatever it may be, Spanker here, and today we're going to be talking about these little devices. This is a Arduino. It's not blue, but it's an Arduino, or a clone of one anyway. So we're going to be talking about what this does, what it's for, what you can do with it, and then in later videos we're going to build some circuits. So we're not building anything today. We're going to go through what you will probably need to start building it, an approximate cost, and what you can use them for. This little one next to it is an Arduino. Well, it was. It's exactly the same really, for all just smaller. And then this one at the very end is an even smaller one. So we're not going to be using them, so let's get rid of them. We're going to be looking at this. Essentially what this does is it's a prototyping board for making something electronic and programmable. These are ones that you will probably embed into a final circuit when you've made a circuit board, but for testing it's better to use these, they're easier. Now what you do with these, and the reason they're better for testing, is because all the pins that you need to access you don't need to solder. You can just get some cables like this and plug in, and it's a solderless connection. So let's just have a look at the board. If I can get it closer, and if I can just try to autofocus the camera. I turned it off before because it was doing my nut in. Let's have a look if it'll autofocus onto it. No, it won't. Let's try and just manually do the focus. Let's just see if I can get that. Okay, that's not too bad. So what we've essentially got, so along the bottom here, these pins, we've got power. I don't know if you can read them, but they are 5 volts, 3.5 volt, couple of ground pins, whatever. We've got some analog in pins, inputs, and then across here, this top one here, we have the digital pins out. We have a reset button. Let's get that back on camera. A reset button here, a couple of crystals on it. We have a power port, which is bog standard power supply. I think it's 5 volts it takes. And then we have this tiny micro USB port. The chip, the main gubbins of the chip. Let's see if this, how good this camera is. Can I focus on what that chip? It's upside down. So let's get this focus right. There we go. We can actually read, if I can keep my hand still. It's a Mega 32 Mega 328p. So it's based on the Mega chip, and it's this is a clone of the Uno i3. Arduino is open source, and they were inevitable to get clones. This, I think, cost £4 delivered. So I don't think in the UK you could buy 10% of these components for £4. Double-sided board, and what's nice about this board is these little holes that we have here. because with them holes it's dead easy for me to use one of these test meter. You'll probably need one of these. This is not a very expensive one. We have an even cheaper one. As well. I think that's about £3. That's maybe 15 to 20. I've got another more expensive one somewhere. It's down here somewhere, this one. But that was one I'm going to use, I think. We're not going to be doing anything dangerous with any dangerous high voltages, I don't think, so this one will be sufficient. So I've got it set at the moment to continuity, so I just want to just quickly go through how I would use this on these boards. So as we go here, as we look at this pin here, I don't know if you can see it on the camera, that pin, the fourth one along is labelled ground. So we've also got at this side here, these two pins are labelled ground. So let's just see if they're the same ground. Yes, they are. So they're joint pins. These little holes make it dead easy to get these pins in. You don't have to fiddle about down here. You're not messing about on these pins here. I like them. Anyway, we'll go back to that in a second because we're going to talk about what else you would need to get kicked off with Arduino. This in itself will do nothing unless you program it, so you need to learn a little bit about programming, but there's tons of tutorials and we'll be going through some as we get on these videos. What I've got here is what the official name I think is prototyping board, but it's well known that these are called breadboards. And basically it's again very similar to these pins. They just allow you to make solderless connections. So I can plug this wire into that, and I've made a connection from that to that board. So some things that you need to know about these boards, how they work. This particular one, and they'll all be different, running down each side here we've got a positive and a negative. Now this positive all here, this pin 1, we'll call it pin 1, is connected to every pin on that row down there, and we'll do a little bit of a proof of that by sticking a wire in this end, and we check the continuity. And that is connected. It's not now because I've just unplugged it, but it was connected. The negative is exactly the same, and what that enables you to do, these on this side aren't connected to that one, but they are connected to each other, but they're not connected across the board, just vertically. What this enables you to do is if you've got a power supply, you can bring off your power supply and put your positive into there, your negative or your ground into there, and it powers that entire rail. Once that rail's got that power, if I need to bring power into any of these ports here, I can just tap off that and it's providing me a power source straight onto these boards, onto these pins as such. What we also need to look at is how these are connected, and what these are connected in is these 5 pins here are all connected together, and they're connected together and they're connected to nothing else. Same for them, and all the way down we've got 63 rows. All them 5 pins are connected horizontally together. So the power is connected vertically, these are connected horizontally. And we'll do another proof. We'll go into that pin and that pin, and we should get, oh, I just got a bit stuck, we should get continuity again. Yes, we do. If I put it into the pin below, we shouldn't get continuity unless something's gone real wrong. Yeah, nothing. This centre of the board, this slot, there's no connection from this side of the board to that side of the board whatsoever. So all them are one connected horizontally 5 pins, and these are as well. So in effect we've got 126 separate rows which are connected with 5 pins each. What this is very good for is when you've got one of these Arduinos, all the pins pop out the bottom. And what I can do is I can drop that onto that breadboard and push it in, shove it in. I'm not going to shove it in because I'll just need to adjust the pins slightly, and I think some of them are bent. Let's try this one might do it. So that's it, I push that into there. It's not properly seated in, but it's you get the idea. And now every pin is on a separate track. They're all on separate tracks, and I can go off using these 3 remaining holes to do whatever I want to do with any circuits. So get one of these. These are only cheap. If you get it from China, eBay it from China, you can get a job lot of them for a tenner. A job lot of them. So what do we do with it? Basically what this does, it enables us to make an electronic circuit out of here which is controlled by this board, which is controlled by the program that we write, and we can then put inputs into it, which could be physical inputs, buttons, switches, they can be sensor inputs, and the program will react to whatever input we put in by sending an output to something else. So you might press a button here and an LED comes on here. You might be able to program it that you press a button, the LED doesn't come on till it's counted you've pressed that button 10 times, the LED comes on. You can then get sensors, so you could get a temperature sensor on here which would tell the Arduino what the temperature is. Then you could get it to fire a relay to turn your central heating system on. And essentially this is what thermostats use a microcontroller to do, things like that, which is programmed. This just enables you to program your own microcontroller. And we've got a lot of different sort of add-ons as well. So let me just grab a couple of add-ons. Okay, so what we have here is we have this, which is a 2.8 inch TFT LCD shield. So that basically is a screen. Once we've got that up and running and connected, these pins connect. In fact, this one's not a very good one for that point of view, because when I connect, you can plug these directly into this. So this will plug directly and sit on top of your microcontroller. It's not a touch screen, this one. I have got a touch screen one somewhere, I think. But that essentially, once you've wrote a program, you can display information on here. So you could, like I say, have this as a thermostat with your settings displayed on screen, put it in a nice little box and have that controlling your central heating system. We've got, this is another screen, this is a slightly smaller one, and this is obviously it's virtually the same. When we look at it on the back, it's very, very, very similar. So we've got the I think that's an output ribbon cable. We've got a couple of chips which are labelled exactly the same. That's labelled the same. What have we got there? We've just got, there's one little different part on there, although this one doesn't have a reset button. This one does. But it looks like this screen has been stolen from a mobile phone, because it's got these permanent little home, address book, messages, camera, screen on there. So this screen has been cannibalised from a mobile phone. Interesting. Reset button's a bit skew with as well. And then this one, which is a little bit interesting, this one, because this one is a LED and key, and we've got 8 LEDs, we've got 8 7-segment displays. Well, there was actually the 2 units with 4 7-segment displays in them, and we've got 8 momentary push buttons, and we've got a, what's that, TM1638 chip, and then the inputs here, so we've got VCC and ground, and then 3 inputs which will control this. So this must be never used this. I don't know how much it cost. It was about £1.50, something like that, because I won't spend that amount of money. What's interesting about it is I think this can be connected to a Raspberry Pi as well, and a lot of things between Arduino and Raspberry Pi that are very, very similar. So this must use some sort, this is using, obviously because of the inputs, it's using that as a data out, and then there'll be a shift register to control them, I should think, but we'll have a look at that at some other point. Well, that's that unit is going to be way down the line, way down the line. I don't think I've got anything else, turn that off, to show us in the peripheral what is. So that is basically it. You use an IDE code from which you get from Arduino.cc, and in the next video we're going to fire this thing up, and we're going to look at some of the programs that come built into the Arduino IDE and see how we go with that. So we'll get to the good stuff next. That's what we'll do. We'll get to the good stuff, the tinkering about, and that is going to be it for today. That's me, Spanker out.